right, people, welcome back. So today we're dealing with problem 35, search insert position. So given a sorted array of distinct integers and the target value, return the index if the target value is found. If not, return the index where it would be if it were inserted in order. You must write an algorithm O log n runtime complexity. Okay, it was very easy in ON. But O log n, this is more interesting. So the target is 5. Binary search, a simple binary search. So we can write down n as the length of nums. And then we can basically iteratively so while true, why not? So basically we continue, and each time we divide our window by n. So let's initialize I as 0 and j as n, and then while true we simply look at nums I plus j divided by 2. Maybe here we have a double 2, like a double slash, and then if nums is less than target, then of course I want e to be initialized as I plus j divided by 2 plus 1, and I want j to be not changed at all. Else if the opposite happens, is greater than the target, then it's j that has to be initialized to that. Else, that's it, we return I plus j divided by 2. So this is what we need to do binary search. Then what we need to return is the index if the target is found. But if not is found, if it is not found, interesting. Okay, anyway, here I think we can clean a bit. So for example, okay, this is gonna throw an error because we need to add parentheses, but then we can then take advantage of this to create a mid variable. So let's write if while I is less than j, so that we have the escape for this while loop, and then we define the mid value as I plus j divided by 2 with 2 slash so that we avoid any rest, and then it's I plus j with parentheses so that it doesn't throw an error, and then I can write down mid here, and then of course I can write down mid plus 1, or here instead it was even wrong because it's a mid minus 1, and here of course we return mid. Yeah, this should work. But this, of course, is a normal binary search. But we want to return the index where it would be if it weren't inserted in order. So here, for example, in this case is correct because we wanted to find 5 and we found it. But here, there was no 2. So how can we do that? So if we end up in a binary search, for example, let's say that we are between 3 and 6. And we're looking for, actually, we're looking for 2, so we are between 1 and 5. We don't find it. What we return? We return this, basically. We return this value. The while loop stops when I and j are the same number. So where I and j are the same number, we are at the number, at the index. So can I just return I? Okay. I'm not, like, apparently it was correct. To be honest, I am a bit surprised that this is true, but no, okay, it's not always true. For example, in this case, the output should be 1, instead it is 0. I don't know, I say that here j cannot be initialized to n. I don't know if this is related at all. Wow. Okay, so by just diminishing j by 1, we created a lot of problems. Why? Because here we want a less or equal, maybe. Okay. To be honest, I don't really understand which are the implication of the fact that before there was n and minus and less than. But now we get another problem, which is list index out of range. Oh, that's because again, here we want mid. Let's try again. And now it works. Okay. To be honest, it feels very strange to me what happened this time, because I do not understand what was not going well before and what's going good this time. I think that basically, while we insert j as n, which is not a right index, we are creating problems in the way the array, like the indexes, are intended in Python. Well, this is more correct, and that is why in some scenarios we may throw an error with the previous initialization. Yeah, I think so. Well, apparently the problem is solved, and this is for sure solved in log n, because this is basically binary search plus the addition of returning the lowest number. So yeah, guys, this was an easy problem. Thank you very much for watching this video, and see you in the next episode.